Hello, my dear friends. The question on the board is very simple, and we're going to look at it critically this moment. The question is a stone is projected vertically upward with a speed of 30 meters per second from the top of a tower of height 50 meters. Neglecting air resistance, determine the maximum height it reached from the base of the tower. All right, you can't just start solving this question, you need to understand it first. So the first thing we're going to do is to bring out the data that the question contains. So we are going to look at the data, the information that the question contains. That's the first thing. All right, here we have initial velocity, okay? The initial velocity is the first thing we're going to bring out. That's under the data. All right, initial velocity is given as a 30 meters per second. All right, okay. Then from there we take it from the from the top of the tower of height. So the tower has certain amount of height given as h is equal to 50 meters, right? Okay. They say neglecting air resistance, that is the influence of air, okay, on the object. Determine the maximum height. So we are looking for h max. H max is unknown. Unknown. That's what we are looking for, right? Okay. That's being said, the question has to do with motion under gravity. So we cannot solve this question without considering the value of the acceleration due to gravity, and is given by letter G. So G is given as 10 meters per second. So with this, we can confidently resolve this. So these are the parameters now. Now let's look at the schematical representation of this question. Let's see how this can be represented diagrammatically, right? Okay, that will give us a pictorial arrangement of solving this question. Okay, let's see. If we take this as a hypothetical representation of the tower itself, right? Okay. Now the height of the tower is given as h. H, that is 50 meters, right? Very good. At the tower, right, an object is projected. At the top of the tower, right, an object is projected vertically. Look at it, projected vertically until it reaches a certain height, stays momentarily at this point and begins to come down and begins to fall down once again. Okay? That's the illustration until it hits the base. This is the base of the tower. Okay? Well said then. You can see the object at this point also maintains certain height before coming down. So it was projected vertically upward. So we take that into consideration. Alright, so if we represent the maximum height attained by the object with small letter h, so it corresponds to the maximum height we are looking for. Alright? That is it. By the time we find the value of h, I repeat, by the time we find the value of this small h and add it to the height of the tower, we will get the maximum height the object attained before falling down, before reaching or hitting the base of the tower. Okay, but there is something we need to understand here. There are two things we need to understand here. Why the stone is being projected vertically upward, it moves in opposite direction. It moves in opposite direction to the direction of acceleration due to gravity. So gravity here, the motion of the object with its gravity is negative g, right? Why at this point the final velocity v is equal to 0. So these are things we need to understand first before delving into solving this question properly. All right, having said that, The next thing we're going to understand here, or going to look at before applying the appropriate formula, is the summation of this. Okay, having said that, the maximum height, h max, can only be found by considering the height of the tower and then the small heights attained by the object itself when the object is projected vertically. Alright, so that is it. We have this. We can call this relation 1, okay? Then we have another one, which is one of the equations for motion under gravity, as v squared is equal to u squared plus upon minus, depending on the orientation of the object being considered. Okay? That is it. We can call this a relation 2, right? If you here, relation 2, relation 1. All right. So, but at the maximum, at the top of the tower, final velocity is 0. So it's meaningless. You might not consider that. But let's see. The next thing we are going to do is to substitute accordingly. We have to substitute. So for v is 0 at the top of the tower. I repeat, at the top of the tower, v is equal to 0. So we put 0 at this point, 0 squared, and then the object is moving with an initial velocity of 30 meters per second from the top of the tower. So that is 30 meters per second, that's squared now. The object is projected vertically. That means its motion is in opposite direction to the motion of acceleration due to gravity, or to the direction of acceleration due to gravity. So we assume minus 2, all right, times 10, which is the value of acceleration due to gravity, and then times h, the small h we are looking for, right? We are looking for this small h. Okay? So if we do that, we arrive at this vanishes. So there is nothing here again. We have this is 0, this is 900. Of course, 30 squared will give 900. Then the next thing we consider 2 times 10 times h will give 20 h. All right. So that is it. Gradually, we are resolving it. Okay. The next thing is to make h, the small h, that is the height the object attained at the top of the tower, the subject of the formula. So we can try that here, and that becomes, we pull this 900 over, the equality sign becomes minus 900, right? Minus 900 is equal to minus 20 h, right? Okay, so that is it. We have done that. We are going to cancel out where necessary. We can still rewrite this in this format, or minus 20 is equal to minus 900, okay? And then we cancel out. Minus will take care of minus, and that does it. Then the next thing we have, this is minus 20 h. So we are left with 20 h is equals to 900. All right, so if we now consider dividing through with the number 20, so we have 20 h all over 20 is equal to 900 all over 20. Okay? This will take care of this. All right? And then here, 20 will take care of 900, and this will give us 45. So h is equal to 55 meters. Okay? That's the value of the small h, of this small h that the object attains before falling down. But that is not the maximum height. For us to understand the maximum height, we need to check from this base to the point it's reached before falling down. So, and that is what we're going to do now. So, maximum height, h max is equal to h capital, the height of the tower, and then the height the object attains before falling down. And we have the height of the tower is 50 right? Okay? The height of the object is 45. Are we there? Okay? And this will give us total of 95 meters. Okay? To give us total of 95 meters. That is the maximum height. Okay? This is the maximum height the object attains from the base of the tower. Alright, my dear friends, it has been simplified, it has been solved, and that is the answer. I want to thank you so much for your time, for watching this. You can subscribe to our YouTube channel at Levi Kingsley. Follow us on Pinterest, Instagram, Twitter, LinkedIn. You can as